So here already we have been discussing the previous types of collector, where concentrating collectors are two types, one with solar tracking and one with without tracking. We have seen different types over there. So here what happens, usually in the concentrating collector we make use of a mirrors, reflecting types. We make use of a mirrors, that could be your concave reflecting surface mirrors or Fresnel lenses we can say. So which is of a combination of these lenses in a linearly connected in series. So these lenses will be made use for a concentrating collectors here. So here not only reflecting the surface, in the collector we make use of different types of collectors, like it could be parabolic, or it could be spherical, or it could be flat collector. Anything can be used. So based on which type of reflective materials you are using, whether mirror or convex lens or Fresnel lenses, so whichever you are using, so based on that, whether I am using a parabolic, so we will come into the next topic. So different types of concentrating collector, that is parabolic, flat and spherical, and apart from this there are few more types that we will discuss in a coming topics. And this concentrating collector has a serious drawback, few drawback here. So what are that? When I am using a mirror here, the surface of the mirror should be very clean, because if it is the surface is not clean, whenever the solar radiation falls on the mirror, it may scatter because of the dust or dirt on the surface of your mirror. If you have very smooth surface, because of the counter error, we may miss some radiation from the reflector to the observer. So because of that reason, this is one drawback here. We need to always be doing a maintenance for this kind of concentrating collector. So similar like your car wiper. So nowadays if you go for any solar power plant, solar panels will be placed, automatically the panels will be cleaning like a wiper. So they will be placing a wiper, so automatic maintenance can be done, or manual maintenance also need to be done. That is one drawback over here. And one more thing here, while in a concentrating collector, so the degree of concentration and the temperature can be achieved very high, where the temperature will be, if I am concentrating this radiation at a point, suppose say, just I will go here. So if you have a mirrors here, and if it is reflecting, the solar radiations are reflecting like this. At one focal point, let us take one point. If this radiation are concentrated at one point, which will produce very high temperature. So when you are concentrating at a one point, there are few cases I may concentrate this radiation through a line. So instead of point, we will be having a pipes. Assume we have a pipes, and where the fluid will be flowing, I need to concentrate on throughout the line of the pipe. In that case, we may have moderate or high temperature. So whereas in the focal point we get very high temperature, and the degree of concentration will be very high over there. And there are few cases where non-focusing concentrators produce low and moderate temperature also. If I am not using any non-focusing materials like glasses or mirrors, lenses or mirrors, if I am not using, I may end up with a lower moderate temperature. So these concentrating collectors have been classified various type. They have been followed given like this. So not this one, one more. Okay, one more slide is missing. Okay, just I will list out that. So the collectors have been classified on various type. The first one, based on what means of concentration is done, whether I am using a reflector type mirrors or I am using any lens. So based on this also, it has been classified, or based on reflecting surface, whether it is a parabolic, whether it is a spherical, whether it is a flat collector. Based on this also it has been classified, and whether it's a continuous or segmented. So this parameter also it has been classified, and based on formation of images, imaging or non-imaging. So there are few cases we come across in coming topic on SSI. There is a concept called as a heliostat. When you're using this, I should place this heliostat mirror such a way that the shadow of one should not fall on the other. So that I need to increase the height, or I need to increase the height of a tower. So that shading should be avoided. Okay, image of one shade of one mirror will fall on the other. That should be avoided. So based on that also, whether I am using imaging or non-imaging, so this concentrating collector has been classified. And also based on your CC ratio, collector concentration ratio, and operating temperature. If the ratio is required, if ratio is more than, already we have seen, if it is more than 150, the temperature we may obtain 1500 degrees Celsius. We have seen in the previous class the discussion. So based on that also, this collector will be classified. And also based on tracking, whether this collector is having a tracking of solar radiation or if it is a stationary type. So based on this also, it will be classified. So here some configuration. Based on that configuration, these are the 6 types of concentrating collectors. That is a compound parabolic solar collector, and this is a Fresnel lens, which to say solar thermal collector, where we make use of a lens here, and something called as a parabolic trug. It's a something like a where arch type, it will be in this fashion. It will be in this fashion, where so the solar cells will be placed here, something like a arch, semi arch, and we have a cylindrical similarly, and parabolic, and finally the last one, heliostat, which I was talking about many times. So that part. So we'll take one by one here. For the first one, this is a compound parabolic solar collector. So unfortunately, they are not given explanation in the textbook also. They are given only diagram. So there is no much explanation for this. So I will go directly to the second one. So this is my solar thermal collector, where we make use of a lens here. Okay, mirror also we can say a lens. So here in this collector, we usually obtain very high temperature with good efficiency. Very high temperature with good efficiency. And the performance of the solar collector will be very high. So in order to, we can say, we can obtain 400 degrees Celsius of temperature here. I can obtain very high temperature of 400 degree Celsius. So here they are made up of made by a bending a sheet. So the first one diagram you can see, that is a parabolic type. They made a observer sheet such a way that it is in a bending type or reflector materials into a parabolic shape. Hence the name is given as a parabolic shape here. So this one, this part is a parabolic shape. So in this, the metal black tube are covered with a glass tube to reduce the heat losses. So whatever the observer here in this part, so they are shown in a focal point right now. So it will be something like a glass tube or a black tube covered with a glass to reduce the heat losses, and it will be placed along the focal line of the receiver. So right now it is shown in the point. So the other side, if you take other view, it will be in a line, focal line of the receiver. This is a figure for that. And when the parabolic is pointed towards the sun, the parallel rays which will fall on the reflector directly, this is a parallel rays, or sometimes it may fall on the reflector, which will reflect the rays over there on a receiver tube. So where in a tube we will be having a fluid. So normally if you take a commercial and domestic application, we make use of water. So where we can heat the fluid over there. So this method will be sufficient if I am using a single axis tracking of a sun along with the long collector modules. So if I use only one axis tracker, node of tracking the other side, only one axis tracking will be sufficient, so that I can obtain a very good temperature, that is up to 400 degree Celsius. There is one more LFR, we used to say linear reflector, where we make use of a linear lenses over there. So the second diagram you can see. So this is my tower, this part. So on the top of the tower, we have a receiver or observer where the fluid will be placed once again, where I can obtain a maximum temperature by concentrating all the solar radiation using mirrors at that receiver point. So, but usually what happens, there is one advantage in this method, the great advantage we can say. In this type of system, usually flat or elastic curved reflector will are used. Why? Because they are very cheap as compared to the parabolic glass reflector. So whatever the glass I am using here, the parabolic reflector, which are of high cost, whereas the mirror which I am using, which are of very cheaper as compared to the parabolic glass. They make use of an elastic curved reflector here. Addition to this, there is one more advantage. It minimizes the structure requirement as compared to the other one. It minimizes because I am placing a tower. Surrounding to the tower, I will place this glass so that the space will be reduced here. That is the one advantage here. And we can avoid, as I mentioned, shading and blocking between the adjacent reflector. I can increase the spacing between the reflectors. So the mirrors which have been placed here, this one, so the bottom part are the mirrors, the line you can see, those are the mirror which is shown in the linear, but it will be in a circular way. So it will be center, surrounding, it will be a mirrors will be placed such a way that all the radiation will be concentrated on the tower in this way. Okay, so I can increase the height of the observer tower, and also I can avoid this shading and other things, but only drawback will be if you are doing the when I'm increasing height or when I'm making any other arrangement, it will increase the cost of overall system, even though it is cheaper as compared to the parabolic reflector. So in this case, we may end up with a high cost if I am increasing the height of a tower. So next one, parabolic trug solar thermal collector. So as I already mentioned, you can see here. So this is a shape where we say trug, where we have a observer tube in the center and we have a reflector. So that reflector can be connected with a tracking mechanism as shown here. Okay, each trug will be having a tracking mechanism which will track the solar radiation throughout a day, and the fluid will be flowing in that observer tubes. So based on the sun temperature, we will get a heated liquid which we can make use for a further application. And this is how in an individual parabolic trug it will be done. Once again, we have a focal point. The focal point is a tube which is shown here, center. It is a tube. So where all the radiation will be focused at that to increase the temperature. And this is how the receiver will be. This focal point will be in this way, which has a glass cover, which has a receiver tube, so that I can avoid the heat loss which is within that tube. And this is how the tracking mechanism will be done. So this is my parabolic trug solar thermal collector. So usually this will be like a U shape. You can see here it will be like a U shape. And in this system, once again, we may have a temperature till 400 degrees Celsius application I can make use. And it is a low cost technology as compared to other methods. It is very low cost and light structure. I'm not using any heavy materials over here, hence it is a very low cost structure. And usually once again they are using a bending of a sheet, that is a reflector. This entire part, if you take this entire part, is a bending of a reflector sheet, where the reflective materials will be in a parabolic shape to obtain almost a high temperature from 50 degree to 400 degrees Celsius. So this observer will be like with a metal black tube or some black coating. So where it will be focus all the radiation through the to the observer. So where in the observer will be having a glass tube, as it is shown here, glass tube or a glass cover to reduce the heat losses which is happening in the focal line of the receiver. So it is not a focal point, it's a focal line because the tube will be for in terms of kilometer the way the fluid will be flowing in the pipes. So in this method, we try to concentrate sunlight onto the receiver tube that is positioned along the focal line of the trug, and somewhere we make use of a transparent glass tube also for the observer to reduce the heat losses. And once again, this type of parabolic trug often uses single axis or double axis tracker. So sometimes we may have only one side movement, or we may have a 360-degree movement also, that we make use of a double axis tracking. So usually in India we doesn't have this kind of facilities. In Dubai or in California, as per the textbook, it is said that in California multi-megawatt power plant has been built using this method, where it is a with hybrid power plant, solar as well as a gas turbine. So both they have been hybrided and they have been built a multi-megawatt power plant in a California. So next one is your cylindrical trug solar collector. Once again, it is almost similar to the previous case. The only thing here, it is a linear translation. You can see where the focal plane, it is in different way. So whereas in the previous case we had something like a tube where the fluid is to flow, but here it doesn't have any tube type. It has something like a focal line or a focal plane, which you can see in the diagram. So here, so this type of collector will aim at very high angle cylindrical trug, would have a focal plane or a focal line to avoid a scattering of your radiation. Because if you take the other type, the previous case, so where the angle of this curve was very large, so there are chances of scattering of a pulse, so radiation was happening. Whereas here that can be avoided. We can focus at one point, the cylindrical, because of the cylindrical shape, and they have been designed with a low rim angle. So the angle is very low in order to avoid a approximate line focus. So you can observe here the radiation which is falling, there is a maximum radiation is happening collection here, right? So this is how they have been made a arrangement so that I can obtain try to extract maximum radiation from the solar, so that it will be useful for the application where it could be your high temperature or the low temperature application in both the case. In this method, the advantage here is the cylindrical mirror geometry is not required, since no tracking, there is no tracking of the there is no tracking for a sun radiation. So because sun in any direction also the radiation can fall and it can focal to the focal plane. So there is no need of tracking mechanism in this method. That is the one advantage here in a cylindrical mirror.